There are a lot of how can this possibly exist type puzzles. This one, for me, is at the top of that list. Just looking at this grid, you're probably thinking, you must have forgot some clues in there, some extra rule to disambiguate this. Nope. This is it. This is the puzzle. This has a unique solution. And it's frankly incredible. I still cannot believe that someone found this. And today we're gonna solve it. The one rule that makes this puzzle possible to solve is the fact that it is a super Kakuro. Meaning that if I were to put, say, a 12 clue here, then in this column, none of these digits could be 1 or a 2, because they would clash with the 1 and the 2 in the clue. And in this row, none of these digits could be a 1 or a 2, and in fact, neither could the digits in this clue or the digits in this clue. That's what Super Kakuro means. I'll leave a link down in the description if you want to give it a try. Be warned, it is not an easy puzzle. There is a fully logical path to find, but it is not a trivial one. So, you have been warned. We're going to start out with two of the more restricted rows in this thing. This one in particular has a lot of digits in it. It's got one clue here. 2, 3, 4. 2 more clues here. That's 5, 6, 7, 8, 9. So at least 9 digits. And because the minimum I can make these 6 cells add up to is 21, I can't make both of these 2 clues add up to less than 10. So one of these is going to be a 2-digit number, and that's going to give us our 10th digit in the row. That means, among other things, this clue has to be a single-digit number. But it also means that we have to use a 0 somewhere. And by the rules, none of these cells can be 0. So the 0 has to go in one of these 2 clues. It can't be a 10, because then the maximum I could make these 2 clues add up to would be 10 plus 9 would be 19. That doesn't reach 21. And it can't be a 30, because I can't make 3 cells add up to 30. So we've got a 20 in one of these 2, along with a single-digit clue. I'll just mark that down here. We've got a 20 and something else, and I don't know which order they go in yet. And now we can start to toss some maths at this row. Let me just make this clue X and this clue Y. We know the sum of all of these digits is going to be 45, because we're summing 0 through 9. These white cells are adding up to 20 plus X. The clues themselves have a 0, a 2, and an X, so that's 2 plus X. So in total, the clues plus the white cells are going to make up 22 plus 2x plus y. If we drop the 22 from 45, we're left with 23. So 2x plus y has to add up to 23. And both x and y have to be single-digit numbers. There's only 3 ways of making that work. Either x is 9 and y is 5. But if y is 5, then this column is just broken. There's no way of making 3 cells add up to 5. So either x is 8 and y is 7, or x is 7 and y is 9. But if I try and make x 7, remember it's cluing either here or here, it's cluing one of these 2 groups. If I try and make one of those 2 groups 7, they'd have to be 1 plus 2 plus 4, and the 2 would clash with the 2 in the 20 clue. So that means that x has to be 8, y has to be 7. If y is 7, then we know this group has to be a 1, 2, 4. And now this clue can't be the 20, because the 2 would clash in the column. So we get our 20 over here, and our 8 over here. This group has to add up to 8 without using a 2, so it's 1, 3, 4. And this group is going to be the remainder in the row, which is 5, 6, and 9, which does indeed add up to 20. Let's take a gander at this row now. It's got 7 white cells and 1 clue, so that's at least 8 digits. It can't have a 0 in it, because the 0 is already up here, eliminating 0 from here. And it also needs a 2-digit sum, because it's adding up at least 7 digits. So that's going to use up all 9 digits for this row, 1 through 9. And then what can the clue be? You can go through and brute force this pretty easily, there's only one possibility for it. But a cool way of looking at this is to notice that these digits all add up to 45, which is a multiple of 9. And there's a cool property that if you take any number and sum its digits, it will be the same modulo 9 as the original number. So adding all of these up, we've got some group modulo 9 plus some other group modulo 9 that have to be the same. The only way to make that work is if these are a multiple of 9, their modulo is 0. Any other number will leave a leftover. And so the digits of this number have to add up to a multiple of 9. The only multiple of 9 they can add up to is 9, and therefore the remaining digits in this row add up to 45 minus 9, which is 36. So we get a 36 up there. But again, you could also pretty easily see that it has to start with a 3. If it starts with a 3, what are the options? Only 36 works. And this is probably the point at which most people can get to without too much trouble. Now the puzzle really kicks into overdrive, and we have to think about the bigger picture. And the key thing to notice is that these column sums, I can't make them too big. I mean, I could make this guy as much as 17, this guy could be 24, and this guy could be 30. But now, this guy can't go up to 20 anymore. The 2 would clash in this row. It can't even be in the 10s, the 1 would clash. So this has to be less than 10. It can be at most 9. This can be at most 9. This can be at most 9. So we're getting a lot of small columns in this range, just by the fact that the 10s digits up here can't repeat. And of course, the sum of all of these columns in the puzzle is going to be the same as the sum of all of these rows in the puzzle, which is just the sum of all the white cells in the puzzle. So let's go ahead and have a look at the maximum total I can make these columns, and the smallest that I can make the rows. Let's start with rows first, because that's easier to see. We've already got a 20, we've got an 8, and we've got a 36. The 2 remaining rows, the smallest I can make this one is a 15, but if I try and make it a 15, then it would have to be 1, 2, 3, 4, 5, and both the 1 and the 5 would clash with the clue. In fact, if I try and make this clue begin with a 1 at all, the smallest I can make these cells is 2, 3, 4, 5, 6, which already adds up to 20. So the minimum this clue can be is a 20. The minimum this clue can be is a 6. And so for our minimum total on the rows, we're looking at 20 plus 8 plus 36 plus 20 plus 6, which is already a minimum of 90 for all of the rows. For the columns, we're going to add these up a little bit differently. We've got a 7, so I'll go ahead and plonk the 7 in. But for the rest of these, let's have a think about the 10's digits and the 1's digits separately. I can have one column that begins with a 1. I can have one column that begins with a 2. And I can have one column that begins with a 3. And that's all of our options for the 10's digits. After that, we've used them all up. All of the other columns have to be single-digit numbers. And then we've got the 6 1's digits in each of these columns, which can be a maximum of 4, 5, 6, 7, 8, 9. So the maximum total I'm looking at for the columns is 7 plus 10 plus 20 plus 30, that's 67, plus 4, 5, 6, 7, 8, 9, which add up to 39. So 39 plus 67, we're looking at 106 as an absolute maximum, which is only 16 degrees of freedom away from 90. And that tells us a couple things. One, it means we absolutely need to have a 30 column. We absolutely need to have a 20 column. If I didn't have a 20 column, the most I could make this sum would be 86. And there would be no way of making this equation balance. Where does the 30 column go in the grid? Well, there's only one column that can reach 30. The most I can make this one would be 4 plus 7, 8, and 9 is only 28. So this is our 30. And the only way of getting to 30 is with a 6, 7, 8, 9. So we can go ahead and write that in. And making this 30 now has a substantial impact as well, because one of our ones digits is now a 0. All of a sudden this can no longer be 4, 5, 6, 7, 8, 9. Best I can do here is 5, 6, 7, 8, 9, since we've got a 0 for a 30. That's going to knock 4 off of this total, so now we're down to 102. The other thing that's doing is this row now. This is a minimum of 6, 1, 2, adding up to 9. And if this is a minimum of 9, that's going to bump this up by 3. So now we're looking at a minimum of 93. And now we've only got 8 degrees of freedom between these two. That tells us two things. One, we absolutely need a 10 column in there somewhere. We're going to have all of the 10s digits we can get in the columns. The other thing that lets us do is start marking in ranges for these guys. If we only have 9 degrees of freedom, then this can go from 9 to 18. That's the absolute maximum I could put there. And this can go from 20 to 29. So we absolutely have a 2 in this clue. This can't be a 2. And what's more, we need a 20 in one of these columns. This column can't be a 20. This one could be. This one's already a 30. This one could be. And this one could be. This one can't be. But now an interesting side effect of having a 1, 2, and a 3 as 10s digits, and the 0 for the 30, is that the digits 0, 1, 2, and 3 are all used up. We can't have those anymore. So the minimum our 20 can be, can't be 20, can't be 21, can't be 22, and it can't be 23. The minimum I can have for it is a 24 plus. And I cannot make this column a 24 plus, not without making it 7, 8, 9. So that's no good. And now this is probably the sticking point for most people. It takes a lot of logic even to get to this point. But now you have to really dive down and figure out what the fundamental restriction in this grid is. And it's the relationship between this column, this row, and this column. And the easiest way to view this, I think, is to notice what happens if I try and make this a 9 to the columns that have to be 20s. If I try and make this a 9, this column can no longer have a 9 in it. So the most it could be would be 6, 7, 8, making 21. Therefore this column, which if it's a 20 has to be 24 plus, could not be the 20. This being a 9 forces this row to be a 6, 1, 2. And now that's a problem for this column, because the most I could make here would be 4 plus 2 is 6, plus 8 plus 9, that's 17 plus 6 is 23, does not get us up to 24, and even then, I would have to use a 2 here and a 4 here, so 24 just isn't a viable option here. So making this clue a 9 simultaneously breaks both of our options for the 20 column. And therefore this clue cannot be a 9, it has to be at least a 10. That has an interesting impact on this clue. Now that this for sure has a 1 in it, it means two things. One, it means that I can't put a 1 in either of these two cells. So they're a minimum of 2 plus 3 plus 5 is making 10. So this is a minimum of 10 as a clue. But it can't be anything in the 10s, because they all start with a 1, and the 1 would clash in the column. So actually, this does have to be the 20 clue, and it has to be a 24. It's the only way of making it small enough. And the only way to make 24 is 9, 7, and 8. Let's just take a pause to update some of our information. This is now a 10 at least, so this has gone up to 94. And this, now that we've got a 24 in the grid, no longer has the option of being 5, 6, 7, 8, 9. Best I can do is 4, 6, 7, 8, 9. So we've lost 1 degree of freedom here as well. This is now down to 101. That 1 degree of freedom, we're now looking at a difference of 7 between these two. So this can be at most 18. Actually, it could never be 18 because there's an 8 in the column and there's a 7 in the column. So this can be at most 16. And this, with 7 degrees of freedom, is coming down to 27 at a maximum. This 9 gives us a 6 here, 5 here, 6 comes out of all of these. And now we can start to look at these rows, which suddenly have some pretty big digits in them. This one in particular, the minimum I can make these add up to is already 15. These 3 cells can't have a 2 in them, so the minimum I can make them add up to would be a 1, 3, 4. And 8 plus 15 is already 23. So that's cranking this up a bit. This is now a 23 to a 27. And this total as well, now that I know it has a 1 in it for sure, 1 comes out of this cell. This cell can't be a 1. So the minimum I'm looking at here is 2, 3, 7. That's making 12. So this is at least 12. And now all of a sudden our equation's getting very restricted. If this has to be at least a 23, and this has to be at least a 12, that's another 5 degrees of freedom that have gone out the window. This is looking at 99. We've only got 2 degrees of freedom to play with here anymore. And so this is somewhere between a 12 and a 14. And this is somewhere between a 23 and a 25. Actually, this guy can't be a 14 because there's a 4 already in the column. So this is either a 12 or a 13. And it can't be a 12 because there's already a 2 in a column. So this we know for sure is a 13. This can't be a 9 now because 9 plus 2 plus 3 is making 14. And these options can be a maximum of 4. 2 plus 4 plus 7. Because this is a 13, can't have a 3 in the row. So this is adding up to 6 in order to make 13. This is a 7. 7 comes out of those two. 1 more degree of freedom gone down here. This is now a 13, so this is looking at least 100. And this guy has to be either a 23 or a 24 in order to make it work. So if this is adding up to 15 at a minimum, and this is adding up to 8 at a minimum, this group has to be either 134 or 135. But either way, it's working with a 3 in it. And that means that this can't be a 23. It has to be a 24. And now we've absolutely maxed out our equation. This does have to be a 24. This does have to be 101. This has to be 101. And that means that the remaining columns do have to be 6, 7, 8, and 9. And one of them will start with a 1. This group, in order to make 24, now can't have a 4 in it. So this is our 1. So this has become a 1 with a 3, 5 pair. That's already adding up to 9, so these have to add up to 15. And that's going to be a 7 with an 8. That gives us our 9 and 8 up here. This clue we know now has to be a 6, 7, 8, or 9. 6 would put a 1 here, that's okay. 7 would put a 2, that's no good because of the 24 clue. 8 would put a 3, which is no good because of the 36 clue, and 9 would put a 4, which is no good because of the 24 clue again. So this is a 1, this clue is a 6. And remaining over here, we now have 7, 8, and 9 as 1's digits. This has to be a 7, 8, or a 9. In fact, this one has to be the one that starts with a 1, because I can't make it a single digit sum. So this is 1 something. It's either 17, 18, or 19. This is 7, 8, or 9, and this is 7, 8, or 9. The fact that this does start with a 1 means this is not a 1. This cell, well, the remaining cells in this row, because they can't be 3 or 6, they have to be 2, 4, 5, and 7. If I made this a 2, 4, 5, then we're looking at 2, 3, 4, 5 quadruple in the column, and that's only adding up to 14. So that's no good. This can't be 2, 4, 5. It has to be 7. That means that this is not in fact 17. This is either 18 or 19. In order to reach as high as 18, if I tried to make this 2, 3, 4, that would only get us up to 16. So I need a 5. This has to be the 5. 3 comes out of here. Now that we've got a 3 in this column, these can't add up to 7. In order to make 7, it would have to be a 1, 2, 4. So the 7 is going up here. If these two add up to 7, this can't be a 1 because that can't be a 6. So it's a 3, 4 pair, and this can't be a 3, so that's a 4, 3, 4, 1, 2, 4, 2. These are now adding up to 4 plus 7 is 11, plus another 7 is 18. So this is our 18. This has to be our 9, and that does indeed check out. And we're through the puzzle. From start to finish, a resilient solve. Interesting logic the whole way through. And there is actually a logical path to be found. I'll have to admit, when I first solved it, this step with the 9 and the 220 columns felt a bit bashy, a bit like bifurcation. But I think if you consider the options, how this 9 plays with this column, if you put a 1 here, it eliminates 1s from here and 1 from there, making that a 20. There's a lot of restrictions going on here, and if you can somehow keep all of those in your head all at once, it's pretty obvious there's only one way that it falls apart. So yeah, I really like this puzzle. This is a really cool puzzle, not because of the solve, but just because of the grid. But if that's the only thing that's wrong with this solve path, then I can forgive it, because this is such a beautiful grid. The fact that this entire thing resolves with no digits, no clues, just the geometry of the grid itself, and even right down to the finish, resolving this 7, 8, and 9, working through the options here. It's just something special. I hope you enjoyed it as much as I did.